All right. Okay. So, you ready? Put your phones away for a little bit, please. Turn off the music. All right. So solve x minus the square root of 15 minus 2x equals 0. They want you to isolate the radical. All right? So I'm going to add the opposite of that to both sides. All right? I'm not going to add each term. I'm going to add the entire expression. If the entire expression had an addition in front of it, instead of adding, what would we do? Subtract. Make sense? Everybody good? Okay. When I do that, the left-hand side is going to become x. All right? The left-hand side is going to become x. And the right-hand side is just the square root of 15 minus 2x. This is what we mean by isolating the radical. The radical's on the right-hand side all by itself. The opposite of a square root is squaring both sides. So I'm going to square both sides. Like we just mentioned, when we square a square root, they cancel out. And I got 15 minus 2x. On the left-hand side, when I square x, what polynomial am I going to have? X squared. Now you're going to solve it. You don't have to do completing the square. You can just solve it the way we have. X squared plus 2x minus 15 equals 0. We get it in standard form. If you want to use quadratic formula to solve it, go ahead. You can. All right, there's going to be no means that you have to solve it anyway, unlike last Friday's quiz. But if I do factoring, that becomes x plus 5, x minus 3. Then we have the roots. The opposite of positive 5 would be negative 5. The opposite of the opposite of negative 3 would be 3. Okay? So those are your algebraic expressions. You get all that right, it's a 4 out of 5. Then you have to plug them back in. All right? If I plug 3 back in, this becomes 3. 2 times 3 is 6. 15 minus 6 is 9. So I start with that. 3 minus square root of 9 equals 0. What is the square root of 9? It's 3 minus 3 equals 0. Yes, so 3 is good to go.
Why don't you use the
I'm going to do both.
Where's the 15 now?
A factor. This 15? A factor.
So what equation are you plugging in?
I'm plugging this back into the original. The very first thing they give you. What's the matter? I'm plugging 3, my answer here.
It's 15 minus 6.
Yes.
Okay.
Alright, it's okay. So now I'm going to plug in negative 5. That becomes the square root of 5 minus the square root of 15. I got you now. Equals 0. So that's what I'm going to do. So that makes sense now?
Yeah.
Alright. It is just negative 5. I wrote square root. It should have been negative 5. Alright? And that's a minus equal to 0. A negative 2 times a negative 5 turns into a what? Positive 10. 15 plus 10 is 25. So this becomes negative 5 minus the square root of 25 equals 0. What is the square root of 25? So this becomes negative 5 minus 5 equal to 0. Negative 5 minus 5, however, is negative 10. Is negative 10 equal to 0? No. That is what we mean by an extraneous solution. So negative 5 is not an actual solution. So you're doing all the algebra, and then what are you doing? Plugging back in. Okay, you're plugging back in. On a side note, if any of you are juniors taking the PSATs on Wednesday, you get an equation that looks like this, multiple choice, plug in the answer choices, and move on with your life. So don't even do all this because you're going to have to plug back in for extraneous anyway. We may talk a little bit about that tomorrow. All right, on the back. Solving an equation containing two radicals. Now, on a side note, I'm just going to put this up here. Square root of 2x plus 3 equals square root of x plus 1. If my equation looked like that, could I just square both sides? Yes. And then what would the square roots do to each other? Cancel out. Does that make sense? So if you see something like that, you're not going to go through all this. The difference is we have a number 1. So we added a side note that says isolate the radical as best as possible. You're not going to be able to do that for this one. So that becomes plus square root of x plus 1 plus square root of x plus 1. On the left-hand side, what does the negative square root of x plus 1 and the positive square root of x plus 1 do to each other? You're welcome. Cancel out. So it's gone. So now I have the square root of 2x plus 3 equals 1 plus the square root of x plus 1. One of the square roots is isolated. This is what we mean by isolating as best as possible. You're not going to be able to just get one all by itself. So I'm going to square this side. I'm going to square this side. On the left-hand side, the square root and the square do what to each other? Cancel out. So I got 2x plus 3. Now, on the right-hand side is where the work comes. This becomes 1 plus the square root of x plus 1 times 1 plus the square root of x plus 1. If you choose not to write it out, that's a choice you make. But please realize it's not just the square of the terms. So it's not going to just give you 1 plus x plus 1. It doesn't work. Instead, it gives you 1 plus 2 square root of x plus 1 plus x plus 1 equals 2x plus 3. Does anybody need to say how this became this?
Yes.
All right. I'm moving it. I just had it right on the side. So I'm doing the distributive law of FOIL. I'm doing 1 times 1, which is 1, plus 1 times the square root of x plus 1, which I'll write out as that.
We had 2 times x plus 1.
Hold on, I'm not done, brother. Now I'm going to take the second term and multiply that term. So I'm going to do the square root of x plus 1 times 1, which also gives me 1 square root of x plus 1. And then plus the square root of x plus 1 squared.
Yeah.
Good?
Yeah.
That's what gives me the 1 plus the 2x plus 1 plus x plus 1. Good?
Yeah.
Okay. Now, this is what we mean by being very conscientious about your work. Don't try to do too much at once. So the left-hand side is going to stay exactly the same. I'm going to put together the 1 and the 1, and that gives me 2. So this becomes x plus 2 plus 2 square root of x plus 1. So all I'm doing is combining like terms. You with me? All I did is put this 1 with this 1 because I could. 1 plus 1 is 2. This stays exactly the same, and I just moved back to the front. In other words, on the right-hand side, I kind of separated the radicals. Everybody see that? So I'm going to leave this alone, and I'm going to get everything else on the other side. What's the opposite of a positive x? Negative x. What's the opposite of a positive 2? Negative 2. So I'm going to do the same thing on the other side. 2x minus x is x. 3 minus 2 is a positive 1. On the right-hand side, what does the x minus x do to each other? Cancel out. 2 minus 2 also does what? cancels out, equals 2 square root of x plus 1. Now have I isolated the radical all by itself? Now I'm going to square both sides again. So that's what it means by you may have to repeat those steps. When I do on the left-hand side, I'm going to have x squared plus 2x plus 1. On the right-hand side, I'm going to have 4 times x plus 1. The reason being I have 4 times x plus 1. This is a 2 on the outside, and I got to square it. 2 squared is what gives me the 4. The reason I have an x plus 1 is when I square root, what do they do to each other? Cancel out. Your next step should be to do the distributive law. X squared plus 2x plus 1 equals 4x plus 4. I'm then going to once again combine like terms. X squared minus 2x minus 3 is equal to 0. I'm going to factor. X minus 3, x plus 1 is equal to 0. I'm then going to find the roots. What's the opposite of negative 3? 3. What's the opposite of positive 1? Negative 1. What am I then going to do with those 3 and negative 1? I'm going to plug them back in to make sure neither of them are extraneous. If I plug in 3, 2 times 3 is 6. 6 plus 3 is 9. Square root of 9 is 3. 3 plus 1 is 4. Square root of 4 is 2. 3 minus 2 is 1. 3 is good to go.
How did you do that?
What?
How did you get it so in your head?
This is the second time I'm doing something. I didn't do it my whole video. When I plug in negative 1, 2 times negative 1 is negative 2. Negative 2 plus 3 is 1. Square root of 1 is 1. Negative 1 plus 1 is 0. Square root of 0 is 0. I end up with 1 minus 0. They both work. So that is one that does not have any extraneous solution. Okay? Should you choose, there's 10 problems here, you can start on your assignment right away. Yes, but it's due on Wednesday. We're going to talk about it when I'm done going through a few problems about the week, because you may want to take a chance or not. I don't know if we're going to meet on Wednesday or not because of this. Alright, so Wednesday's PSATs, I don't know if we're meeting or not. That's what I mean, so I don't know what. What do we want to do about it? We have quiz on Friday. I'm staying after today, which I'm just going to know. I'm staying after Thursday. Yes, sir. All right. So, alright, so like I said, if you want to get started on them, if you feel good about yourself, feel free. We're just going to do a couple problems real quick. Alright, we're going to do number 1. V equals the square root of 4 plus 3v. So this is how you're going to do 1 through 4. Is the radical on the right-hand side isolated? Yes, it is. So I can square both sides. Alright, everybody good with that? When I do, the left-hand side is going to be v squared. The right-hand side is going to be 4 plus 3v. Good? I'm then going to get it in standard form. V squared minus 3v minus 4 is equal to 0. Again, you don't have to complete the square. You don't even have to factor if you don't want to. Solve it any way you like. But it factors into v minus 4, v plus 1. What's the opposite of negative 4? 4. What's the opposite of positive 1? Negative 1. So those are my two possible solutions. When I plug in 4, what's 4 squared? 16. When I plug it in here, no, I'm sorry, we're not going to square it. It's just 4. When I plug it in here, 3 times 4 is 12. 12 plus 4 is 16. Square root of 16 is 4. Are both sides equal to 4?
Yes.
Yes, so 4 is a valid answer. When I plug in negative 1, 3 times negative 1 is 3, negative 3. 4 minus 3 is 1. But when I plug it in on the left, I just get negative 1. Is negative 1 equal to 1? No. So therefore negative 1 is extraneous. That's all it is. If on a quiz you do that, show me that, and then just put an X through it, I'm going to assume you're telling me that's extraneous. Or you can write extraneous next to it, whatever you like. So that's how we do 1 through 4. Everybody good? All right, let's take a look at 5 through 8. All right, now for number 5, the radical is not isolated. That's a positive 1. How do I get rid of a positive 1? Negative 1. What's 1 minus 1 going to do to each other? Cancel out, giving me nothing. So I have the square root of x minus 1 equals just plain x minus 1. The radical is now isolated. So what do I do to both sides? Square them. When I do, what does the square and the square root do to each other? Cancel out, giving you x minus 1 equals x squared minus 2x plus 1. Everybody good with that idea? When you square a binomial. I'm then going to move everything here over to there. So I'm going to minus x and add 1. I'm going to minus x and add 1. My left-hand side, because everything cancels, is going to be 0. My right-hand side is x squared minus 3x plus 2. If I choose to factor, what two numbers go into 2 add up to 3? Negative 2 and negative 1. So that's x minus 2, x minus 1. What's the opposite of negative 2? 2. What's the opposite of negative 1? 1. So my two possible solutions are 2 and 1. What do I then do to the 2 and 1? Plug them back in. When I plug in 2, 2 minus 1 is 1. Square root of 1 is 1. 1 plus 1 is 2 on the left. When I plug it on the right, I also get 2. So I'm good to go. When I plug in 1, 1 minus 1 is 0. Square root of 0 is 0. 1 plus 0 is 1. When I plug in 1, I get. So they both work. So neither of those is extraneous. All right? One more, and then you're off to the races. Number 9. Number 9. Not number 9, sorry. Well, we could. How about we do 1 instead? On the left. So we're doing that one. Square root of 3x minus 8 equals the square root of 2x minus 7 plus 1. I'm squaring both sides. Everybody good with that? Because the one on the left is isolated. Again, you're not going to be able to isolate both. That's going to give me 3x minus 8 over there. Equals 2x minus 7 plus 2 square root of 2x minus 7 plus 1. Basically, when you square an expression like this, you're going to end up with the expression without a square root. Does that make sense, everybody? Because when I square a square root, they cancel out. I'm then going to get 2 times whatever that is. Does that make sense to everybody visually by now? And then I'm going to end up with the second term squared. That's all I'm going to have each and every time. That's the structure of it. All right. Now, again, from here, there's some choices you can do. 3x minus 8 equals 2x minus 6 plus 2 square root of 2x minus 7. In other words, I collect like terms. I put the 1 with the negative 7. I'm then going to get everything that isn't a radical on the other side. So I'm going to minus 2x and add 6 from both sides. When I do, I'm going to have x minus 2 equals 2 square root of 2x minus 7. At that point, I'm going to square both sides again. X squared minus 4x plus 4 equals 4 times 2x minus 7. When I square an expression that looks like this, it's going to be the outside number squared times whatever's inside the radical. I'm then going to distribute x squared minus 4x plus 4 equals 8x minus 28. X squared minus 12x plus 32 is equal to 0. X minus 8, x minus 4 is equal to 0. What's the opposite of negative 8? 8. Opposite of negative 4? 4. And then you would plug them both in. 8 on the left gives you the square root of 16, which is 4. On the right gives you the square root of 9, which is 3, plus 1, which is 4, so 8 works. When I plug in 4, on the left I end up with the square root of 4, which is 2. On the right I end up with the square root of 1 plus 1, which is also 1, so they both work. Alright? There.